Welcome to this presentation on gravitational lensing, where we're going to go on a journey to see what gravitational lensing really is and how it works within our universe. Let us begin by seeing what the definition of gravitational lensing is. A gravitational lens is a distribution of matter, such as a cluster of galaxies, between a distant light source and an observer, that is capable of the apparent bending of light from the source as the light travels towards the observer. Oh, whoa, a mouthful. Whoa. I won't be surprised if you get into that. So let's break it up together. First off, let us go back in time to 1912, where Albert Einstein first predicted the idea of gravitational lensing 3 years before he published his work on the theory of relativity. It had occurred to Einstein that if gravity bends space-time, as stated by his findings within his theory of relativity, gravity should also bend light traveling through space. This idea on gravity bending space-time was an idea brought forward by Einstein himself in his theory of the curvature of space-time within his theory of relativity. And this idea coincides with his theory on gravitational lensing. He came up with these two general equations, with the first one being used to calculate the angle at which the light bends at, while the second one is used to calculate the angle if the deflection is small. However, it wasn't until 24 years later where he decided to publish his findings, as he didn't think anyone could observe such an event. But in 1974, telescopes became powerful enough to prove Einstein correct. Now, enough of the history lesson. Let us learn at what gravitational lenses are and how they work. Okay, so let's break the rule up first. The normal term for gravitational means the relative movement towards a center of gravity. However, in the case of general relativity, the term actually means bending space-time. So, heavy masses, such as stars, galaxies even more so, will create distortions in space. The mass doesn't even need to be that massive in order to create distortions. Your mass at the moment is creating a little dimple in space-time as we speak. Lens means a piece of glass or other transparent material with curved sides for concentrating or dispersing light rays. Now, you might say that there is no lenses in space, as there is no curved glasses in space. Wow, that is where you're wrong. As light has no mass, if space is curved, light curves with it. So, if a curved glass can make a lens by bending light, why can't a curved piece of space do the same thing? This diagram shows a very simple representation of this. As you can see, the arrow bends down as the mass of Earth creates a little distortion in space-time. Now, let's put all the information we have learnt so far and put it into context. Let us imagine that the green focus point is us here on Earth. And let's say that the yellow massive object is some distant galaxy. Now, let's say that there was a quasar at the point of source behind this galaxy of ours. Okay, so what will happen is that the light rays from the quasar will go towards the galaxy, and will be distorted by the galaxy's gravity just enough that the galaxy will act as a lens, creating a double image effect. So what that means is that when the distorted light rays reach us here on Earth, we will see multiple images of that quasar behind the galaxy acting as a lens. This image is what we will see here on Earth. As you can see, there are 5 images of that one quasar due to the bending of light from the galaxy. They are here, 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 and here. You can also see three images of one distant galaxy, that is being replicated as well. They are here, here, and here. A better visualization of this is shown here in this video. As you can see, the light rays from that quasar get distorted due to the bend in space-time from the galaxy's mass. And because of that, there are multiple images of that one quasar being replicated when looking at it from Earth. Now, if you were sitting there and wondering, what is a quasar? Well, for starters, it is an active nucleus or center of a galaxy of very high luminosity, and it consists of a supermassive black hole surrounded by an orbiting accretion disk of gas. While some dust and gas fall into the black hole, other particles are accelerated away from it at the near speed of light. The particles travel away from the black hole in jets above and below it, creating their distinctive look, as you can see off into the distance. These things are immensely bright. The most brightest quasar ever found emits light 429 trillion times brighter than that of our own sun. Now that is bright. No wonder they are the main light source for gravitational lensing. Anyway, I think that everything that you need to know about gravitational lensing and quasars too as a little bonus. I hope you learned something today. Thanks for watching.